going to be a little bit different, but it's still pretty simple. I'm going to open up a new file just for demonstration purposes. You don't have to actually follow along on this. And to actually access a environment variable, we have to import the OS module. And then to access that variable, you say os dot get nv. And then within this method, you just pass in the name or the key of the variable. So in this case, it's path. And I'm just going to store this in a variable, and we can call this anything. I'll just call this path. Why not? And then I'll print out path so we can see if it actually works. So now if I do pi-3 and then run example.py, you can see that it printed out that same exact path. Now to set a new environment variable, we would go to new, and maybe I create a URL, a variable name called Postgres, or we can just call this, how about my_db _URL. So this is going to have the URL to access our database. So I'm going to say this is at localhost :5432. I think that's what our database is running on. And I'll hit OK. And so here we can see that this is our new environment variable that we created, my_db_URL, and it's set to localhost 5432. I'll hit OK. And then I'll hit OK here. And then what we're going to do is we're going to try to access that variable. So I'll do echo my_db_URL %. And actually it should be %%. And you can see that it does not print out what we said. It just prints out exactly what we wrote. So what gives? What happened here? Well, anytime you set a new environment variable, what you got to do is you got to close out your terminal and open up a brand new one. So I can close this out, or I can just open up a new one. And this new terminal, well, actually, I don't want a PowerShell. I want a command prompt. So this new terminal will be able to access newly created environment variables because they get set as soon as the terminal opens. So once the terminal's open, I can't change them. So I have to open up a new one so that it can reread and import all of those environment variables. So now if I do echo %my_db_URL %, it looks like I may have mistyped this. So hold on, let me see what it's called. And that looks like it's correct. So what's happening? Well, I'm going to close out all of them. That's probably what's the issue. So let me open up a new terminal. And I'll open up a new command prompt. And now I'm going to try echo %my_db_URL. And now we can see that we can read it. So we have to close out our terminals and open up a brand new one. It's kind of annoying, but that's just the way it works. Now, on top of that, there's an even bigger issue, and I think this is exclusive to Windows. And that is that VS Code, the terminals here, it's whenever you set a new environment variable, they never have access to it. So you could try deleting all of these terminals and then creating a new terminal and then accessing that new environment variable, my_db_URL. And if I try to run this code, you'll see that it just says none. And if I just try to run the same echo command here, you'll see that it just spits it out. So it's not able to read it, and it's a little bit of an annoying issue with VS Code in Windows. You have to close out every single VS Code window that you have and then reopen them. And sometimes even then that doesn't fix the issue. So know that this is just kind of a limitation with Windows. But ultimately, don't worry too much about that because you're going to see that, especially in a development environment, going into and actually setting all of these variables yourself is unnecessary, right? I don't want to have to go in and set one for my database IP, my database port, as well as my secret key, my password, my username. It's just too many to manage yourself. And you'll see that more complex applications could have 10, 20, 30 environment variables that need to be set. So instead of going into your system and actually changing it, I'm going to show you guys in the next video, I'm going to show you guys how we can get around this by using what's referred to as an environment file. And so you don't actually need to worry about the limitations we're running in here because we're never actually going to set our own environment variables on our local machine, especially in our development machine, because it's just too slow of a process and it makes things unnecessarily difficult to troubleshoot. So before we wrap things up, If you want to delete that environment variable, feel free to do that, which we can just go here and I can just select that and then hit delete. And let me show you guys how to do this on a Mac. To set an environment variable on a Mac machine, the command that we run in the terminal, there isn't a GUI kind of like in Windows. We actually have to use a terminal, which I actually prefer. What we do is we just type in the command export, and then we provide the name of the variable or the key. So I'll say my _db _URL. Then we say equals, and then we just provide the text or the value. So in this case, maybe this is localhost 5432. All right, and then to actually read the environment variables that have been set, you type in print env. And here we can take a look at all the environment variables. Most of these have been set by the machine itself. And you'll see that nowhere in here do we see, well, actually we do see my DB URL right here. However, just like I said in Windows, sometimes, depending on the terminal you're using and a few other things, sometimes you actually have to close out this terminal and open up a new one to actually get the new environment variable. But here we can just access it by typing echo, and then we could just say $my _db _URL. And you can see it prints it out. And then within Python, just like we did on the Windows machine, accessing it is the same exact way. It shouldn't matter which operating system you're on. It's the same exact thing from your code's perspective. With any project, there's going to be a certain number of environment variables. And as I said, as your project grows, you're going to have more and more of them. And one of the issues that you can run into is that you could potentially forget to set one of them, either on your development environment or your production environment, and it's probably going to cause your application to crash. And so what would be good is to perform some sort of validation to ensure that all of the right environment variables have been set for your application to actually run properly. And on top of that, it's important to understand that when you read an environment variable, it's always going to come out as a string, which is fine, but it just means that you have to do all of the validation in code. So if you're setting an environment variable for your access token expire minutes, right? We needed this to be an int, not a string. But when we read the environment variable, it's going to come out as a string. So we have to convert this to an integer. So when it comes to verifying that all of the properties are set, as well as performing validation, we might have already kind of addressed this issue with a different part of our application, right? And that's our schemas, right? We do the same thing with all of the data we send in the body by using Pydantic to perform all of that verification to make sure that every single property that we need is there, and to also perform all of the typecasting. So if we set it something to be an integer, it'll automatically convert it and validate it that it is a valid integer. And what's great about Pydantic is we can actually use Pydantic to perform all of that validation for our environment variables. And let's see how we can actually do that. So I'm going to go to main.py, and as an example, I'm just going to import from the Pydantic library something called base settings. And so just like with any other Pydantic model, right, we can set up a class, and I'm going to call this settings, and this is going to extend base settings. And I didn't mean to accidentally import base. And here we can basically just provide a list of all of the environment variables that we need set as properties on the class itself. And so, maybe I need something called database _password. And this needs to be of type string. And we can even give it a default value, which is localhost. And then maybe I need a database username, which is going to be string. And we can give it, once again, a default password. We don't actually have to give it a default value, but if you want to, you can. And I'll say this is going to be Postgres. And then maybe we want the secret key. And this is once again going to be a type string, and we can just give it, some arbitrary default. And let's say these are the only environment variables that we need for our application to run. By setting it like this, it's going to automatically perform all of the validation for us to ensure that all of these have been set. And an important thing to understand is that when you set environment variables, if we just quickly go back to the environment variables on my machine, normally best practice for environment variables is to do all caps. with underscores, right? It doesn't have to be all caps, but this is just kind of standard convention. You can see I've got some that aren't like that, but in general, you want to do it all caps. And you can see here, we reference it all in lowercase. So Pydantic will automatically handle all of this from a case insensitive perspective. So it doesn't matter if you capitalize this or lowercase everything. It'll take all of your environment variables and it'll convert it to lowercase just to simplify everything. Then we create a variable called settings equals, and then we say settings. So right here, all we're doing is we're creating an instance of this settings class. And so at this point, Pydantic will read all of these environment variables. And once again, it'll look for them from a case insensitive perspective. So it doesn't matter if they're capitalized or not. And then it's going to perform all of the validation. It's going to ensure that they're properly a string and so on. And then finally, it's going to store it in a variable called settings. So then we can access all of these variables by just saying settings dot and then the name of the property. So if I want to get the database password, I just do settings.database password. And so we can print this out. And I'll just start my application. Right? And you can see that it printed out localhost. And if I want to grab maybe the username, I just say username. Actually, sorry, it should be database underscore username. And you can see it prints out Postgres, which is the default values because I haven't actually set my system environment variables to be any of these values. So it's going to use the default one. And like I said, we're going to run into that Windows issue where I can't exactly update it without closing everything. So I'm not going to bother doing that. But what I will do, just to show you how this validation works, is let's remove this. Let's say there's no default password. And so if there's no default password, then it's first going to check my system, my system or user environment variables to see if there's something called database password. And since I didn't provide a default one, if there is no environment variable with that name, it's going to throw an error because the whole point of this is to validate that all of the environment variables that we have are configured here. Right, and so after I save it, if we take a look at this, you can see that we get one validation error for settings. So settings, database password, and we can see that it's missing. Right? And so having that quick check makes our life so much easier so that we don't have to figure out, which environment variable is missing, which one's not. Because like I said, you could have 10, 20, 30, 40 of them. There's going to be a lot of them, and managing them does become a little bit of a challenge. Now, one quick thing, let's say I go to my environment variables once more, and I've got something called path, right? So path is, the path to a specific directory. And what I'm going to do is I'm going to say, I want to access the path, but we're going to say that this needs to be of type int. So Pydantic is going to perform some validation. It's going to read it, and every environment variable is always read as a string. And then it's going to try to typecast it into an int. And if it fails, it's going to throw an error. And so since this is clearly not a integer, it should throw an error. So let's try this out. And we can see that value is not a valid integer. Now, for all of the settings and the environment variables, I usually like to create a separate file to hold all of this information. So under app, I'm going to create a new file called config.py. And I'm going to move all of that code into that file. And then in our main.py file, I'll just import from .config import settings. Right, so ultimately we're just importing that final class, the instance of the class that we created. Right, and so once again, it's able to perform the validation and it's going to report an error with the path variable. All right, so having it in its own file is going to make things a little bit easier because then we could just go to the config.py file and we'll know exactly where to look for all of our environment variables and all the configs related to our application. The last thing I want to do is let's go ahead and actually figure out what environment variables we want to use moving forward and actually set this up. So we're going to clear out all of these, and I'm going to create one for all of the database related stuff. So database underscore hostname. This is going to be a string by default. We're going to have database underscore port. Once again, a string. We'll have a database password. And then we'll have a database underscore name. So that's the database within Postgres that we're connecting to. We'll need a username. All of these will be strings. And you may be wondering why the port is set to a string, but the reason why it's going to be set to a string is because if we actually take a look at our database connection, it just goes into a URL, so we don't actually ever need to have it be an int. I guess you could make sure that it's a valid port number and then convert it back to a string, but that seems a little unnecessary at that point. Then there's a secret key for our JSON web tokens. We've got the algorithm for assigning our token. And then we have the access token expire underscore minutes, which is going to be an int. All right. And if we save all of this, we should get a whole bunch of errors, and that's okay because none of these have been set. So at this point, you could technically, whether you're on a Windows or a Mac, set these on your machine and get everything to work. But like I said, that is an unacceptable thing to do because that's a lot of work. And we want to simplify things. So what we can actually do is within our Fast API directory, we're going to create a new file called .env. So this is kind of standard convention, but this file, and don't forget the dot, this file is going to contain all of our environment variables, so we can set it much easier just by having a file do all of the work. Now in production, you're not going to use this. In production, you're going to actually set it on your machine, but in development, it's perfectly okay to just set everything in here. And so what we're going to do is we're going to take all of those environment variables that we defined, and we're going to provide values. And so like I said, in real life, you generally want to capitalize everything, but luckily Pydantic automatically looks at everything from a case-insensitive perspective. And so our database right now is running on localhost, so we can just say localhost. Our database port is going to be 5432. The password, that's going to be whatever you chose to use as your password. It's going to be password123. And we've got our database name. Mine happens to be Fast API, but yours is going to be something different probably. The username, I'm guessing everyone's probably going to be using the default Postgres. The secret key, I'm just going to grab whatever I used in my file, so I'll just grab this. The algorithm is going to be HS256. And then the access token expiration time is going to be set to 30. So we've got all the values set here. And one thing to note, I didn't provide any default values, and you could 100% go ahead and add default values into yours if you want to, but I'm going to leave them as such. And now we have to tell Pydantic to actually import it from our .env file. And the way to do that is inside this class, we just say class config, and we say env underscore file, and then the path to our specific file, so we say .env. So we'll save this. And I forgot to save my env file. And then I'm going to run this again. And our application should start up with 0 issues. And so hopefully you guys see how easy it is to work with environment variables, especially when you're allowed to set it on a file, so that we don't have to worry about setting it either in the terminal or on a Windows machine having to go through the GUI to do that. But one thing to keep in mind is that you never want to check this env file into Git, right? Because this has all the credentials for your development environment. Maybe you don't want those to get out, and there's no need to ever check it into Git. So if you create a git ignore file, which is .gitignore, you want to make sure that you put in .env. And we'll come back to the git ignore file when we start working with Git in this course. But you also want to make sure you remove anything with __pycache__, which is all of these, as well as your virtual environment folder. So you want to make sure none of those get checked into Git so they don't get uploaded to your GitHub repo. And just to make sure that everything's working, let's go ahead and just test this out real quick, just to make sure that nothing's broken. And that seems to work. And then if we try to get all posts, everything seems to be working. So we have now successfully moved everything over to environment variables. And actually, sorry, we forgot to do one very important thing. We're not actually using the environment variables right now, because if I actually go to my database, you can see that it's still just a hard-coded value. So we have to make sure we actually update that to use the environment variables. So we're going to change this to be an F string. And then here, this is going to be the username. This is the password. This is the host name. And then this is the database name. And then there's also going to be the port number, which would be right here, which is 5432. I believe that's, yeah, and that's going to be the port number. So what we have to do is, since we're using an F string, I can just remove this and I can say, well, first of all, we have to import our config file so we have access to it. Or we can do from config import settings. Just put a dot there. And now I can just say settings dot database, and then we'll grab the username here. And then for the password, I'm going to do the same thing. I'll say settings dot database password. And the host name, this is going to be settings dot database host name. And then this is going to be the port number. And then finally, we've got the actual database name. And I think everything should still work. Just to test this part, let's just quickly log in now. All right, everything still works. So our access to our database is now working just fine. But there's a few other things that I want to update. And keep in mind, if you're using the Postgres driver to actually connect and make queries, then you would just update it here with the settings dot whatever. But if we go to our OAuth 2, we can, well, first of all, let's import our config. And we'll change the secret key. This is going to be settings dot secret key, not schema, secret key. The algorithm is going to be settings dot algorithm. And then finally, this is going to be settings dot access token expire minutes. All right, let's reload this. Let's just double check a few things. So let's create a new user. All right, we are able to create a user. Let's log in that user. We're able to log in, and then let's get posts. And we're able to get posts. And let's just double check that there's no errors. So everything looks good. And so now we have successfully migrated all of our code to using environment variables. And so when we move to production, we can just, on the machine, set all of these values that we have inside our config.py file, and it's going to automatically import it and then update those values wherever we reference them. In any social media type app, there's going to be some sort of voting or likes system. So Facebook has likes, Reddit has upvotes and downvotes, Instagram has likes, Twitter has likes as well. And so we're going to implement a simple like system as well, and we're going to quickly go over the requirements for it. So the first thing is a user should be able to like a post. A user should only be able to like a post once. We shouldn't be able to like a post 10 times and then artificially cause the number of likes for that post to go up. And then finally, anytime we retrieve a post from our database or from our API, we should also fetch the total number of likes for that post. Now let's take a look at the requirements for our voting model or our like model. And so naturally, just like we have a table for users and a table for posts, it makes sense to store the votes in another table, just like we always do. And if you think about the requirements or what we should do for the columns, well, we need to have a column that's going to store the ID of the post that we're ultimately going to like. And then we're also going to need a column that references the ID of the user who liked the post. So those are the two absolute minimum number of columns that we need to get our voting system in place. Keep in mind, if you wanted to do an upvote, downvote type thing like Reddit does, then you might want to have a third column for the direction of your vote. But we're going to keep this nice and simple, and it's just going to be a very simple like system. So it's just one direction. But the most important thing of the vote table is that since a user should only be able to like a post once, this means that we need to ensure that every entry, every post ID and voter ID is a unique combination. So what do I mean by that? Well, take a look at this. We have a post with an ID of 12, and this post was liked by a user ID of 4. So this is what an entry would look like. And that's perfectly fine. And if we go, and here we've got a post ID of 28, and it looks like a user with an ID of 9 liked this post. And if I go all the way down to here, you'll see that post ID of 12, which you can see that there was already a row with the post ID of 12, is liked by a different user, 9. So it's perfectly okay to see a repeat in this column. And under the user ID section, it's perfectly okay to see a repeat in this column as well, because we can see that a user of ID 9 voted and liked a post with an ID of 28, as well as a post with an ID of 12. And then obviously, one post can be liked by different users. So a post with an ID of 12 was liked by a user with an ID of 4, and a post with the same post was also liked by a user with an ID of 9. Now, what we can't have is a user liking a post more than once. So you could see here, user 2 liked a post with an ID of 55. We can't have him do that again, right? It's a duplicate. This isn't allowed, or this shouldn't be allowed in our system, because we don't want users to be able to like a post more than once. And so there's a couple of different ways of setting up this requirement, but we're going to take a look at the simplest solution. And we're going to learn about something called composite keys. So we've already covered what a primary key is. It's a column in your table that's going to ensure that every single entry is unique. And we always used a column called ID, which had a auto-incrementing integer. However, what we can also do is make use of something called composite keys. And a composite key is nothing more than a primary key that spans multiple columns. So we've only worked with one column primary keys, but we can actually have it cover more than one column. It can have 2 columns or 3 columns. And since a primary key must be unique, this will ultimately ensure that no user can like a post twice if we make sure that both of these columns are part of the primary key, right? And so when you have a composite primary key, it does not care if there's duplicates in one row. It does not care in one column, and it does not care if there's duplicates in the other column. All it cares about is, are both of the columns the same in 2 different rows? So once again, for a post of ID 12, we have a user of 4 who likes it, as well as a user of 9 that likes it. And so with the composite primary key, it sees that as 2 different entries because it needs both of them to be the same to be considered a duplicate. So we can uniquely identify this row by saying, hey, I want the row with the post ID of 12 and a post ID of 9. There's going to be no other rows with that combination. And the same thing goes in the other direction. The user 9 can like post 28, and he can also like post 12. And so once again, we can uniquely identify either one of these rows because we can say, hey, post 28 with the user ID, that's a unique combination, and a post ID of 12 with a user ID of 9, once again, a unique combination. However, we can't have a user with the ID of 2 like 55, and then once again, the user ID of 2 like 55, because the combination of these two is now a duplicate, because one is 55 and 2, and the other one's 55 and 2. And so that's all a composite key is. It's just a primary key that spans 2 columns and ensures that across both columns, we have unique combinations for things. So let's figure out how to create our new votes table. And I'm going to first show you guys how to do this within pgadmin, so just with regular Postgres, and then we'll take a look at how to do this with SQL Alchemy. And I'm just going to go under tables, and I'm going to create a new table. We'll call it votes. And then under columns here, I'm going to add a column, and this is going to be post underscore ID. So this is going to be the column that referenced the ID of the specific post. This should, and then actually before we do anything else, I'm going to add the other column in as well. And then we're going to have the user underscore ID. And so these are both going to be integers. And then we can just select primary key, primary key. And that's going to create that composite key. And then we have to set up the foreign keys as well. So these are going to reference other tables. So for the post ID, we can go into constraints, and then we'll go into foreign key. We'll add a new foreign key. And I'm going to call this votes underscore posts underscore primary, whoops, not primary key, foreign key. And actually, sorry, I didn't mean to do that. And then we're just going to go into here. For the columns, we're going to select the local column, which is going to be post ID. Sorry, it's not post ID. Yeah, post ID. And then for the referencing table, it's going to be the posts table. And then we're going to grab the ID of that. And for action on delete, we're going to make sure it's set to cascade so that if the post gets deleted, we're going to delete this entry. And then we'll add that in there. Oh, it looks like it's got deleted. Let me just redo this. We'll add that. And so we've got that in there now. And that should be it for the first foreign key. Let's add another foreign key. And this is going to be called votes underscore users underscore foreign key. Columns, this is going to be user underscore ID of the local table. This is going to reference the users table, and then it's going to reference the ID. We'll hit that. Actions. This is going to be cascade as well. And we'll save that. And then I'm going to right click on the votes table, and then we can go to view, edit data. We'll go to all rows. You can see it's a very simple table. So let's create a new vote first. And so I'm going to, first of all, I've got way too many of these windows, so I'm going to just quickly delete those. All right, so I got those deleted. I'm going to open up a new query. And I can just go into database. We'll do query. And I'm going to do select star from posts, and then select star from users, just so I can get a list of post IDs and user IDs. So I got user ID of 21, 23, 24. And for the post, we got 10, 4, 9. So let's try those out. And I already forgot them. So let's get that post ID again. So we'll just grab a post ID of 10. So this is going to be 10. And then the user ID, well, I'm going to open up a new window so I can just switch between them. So now we have both of these windows for querying, and I can do select star from users. 21. Okay, so we'll do. And it looks like we hit a bug in pgadmin because I can't write anything here. So I'm just going to do view, edit data, all rows again. And that looks a little bit better. So let's get a post 10 and a user of 21. So 10, 21. And let's see if we're successfully able to get that. And looks like that worked. And then if I grab a post ID that doesn't exist, so let's say like 99, and then a valid user, let's see what happens. It's going to throw an error. That's good. And then if we grab a valid post number, but a ID of a user that doesn't exist, we should also get an error. And then if any of these are blank, hit save, it should throw an error as well. Okay, so our table looks set. That's pretty much all we have to do. There's nothing else for these tables. You'll see that once you can create one table, you can really create them all. So I'm just going to drop this table for now. And in the next video, we'll take a look at defining our model in SQL Alchemy so that SQL Alchemy actually generates the table for us. In our models.py file, let's create our model for our votes table. And we'll call it votes, or just vote. It's going to extend base. And then for our table name, I think it just makes sense to call it votes. Then let's set up our two columns. So we're going to have a user ID, and then we're going to have a post underscore ID. So for the user underscore ID, it's going to be a column, and it's going to be of type integer. We're going to set up the foreign key. And this will be users. So it's going to reference the users table and grab the ID field. And then the second property is going to be the on delete, which is going to be set to cascade. All right, then we'll set the primary key to be true. And that's pretty much it. And then I'm just going to copy this, paste it here. We're just going to change this to be, instead of user's ID, it's going to be posts.id. And I don't know why I got auto formatted to a different line. Okay, it looks like that's what it prefers. And so save this, and assuming there's no errors, our application should restart. And then if we go to pgadmin and then refresh, we should see a votes table. And I'm just going to go and take a look at the properties. And you can see that we've got the user ID and the post ID. We've got the primary key set, so it's a composite key. And since it's a primary key, not null is going to be set to yes. We go to constraints. We've got, once again, both the primary keys. We should have 2 foreign keys. And then if we just take a look at one of them real quick, we should see cascade on delete. And so if we go and view and edit data, let's test this out. 10, 21 again. Oh, sorry, it should be 21 and 10 because the user ID is the first column now. 21, 10, let's try saving that. Good. Let's try doing 21 and 9 or 21 and 88. Should error out, perfect. And then let's try 10 and some random number. Error, perfect. Now there's going to be a couple things that we need to take into consideration when setting up the vote route. So first of all, what is the path we're going to use? And I think it makes sense just to set up a new path called /vote. Just like we have for /users when it comes to handling anything with users, and we have /post for handling anything with posts, we're going to have the /vote for handling voting. Now the user ID, the user who's trying to vote on or like a post, the ID of that user is going to be extracted from the JWT token, so we don't actually have to extract that from the body. We don't need to include it in the body. However, the body itself is going to contain 2 pieces of information: the ID of the post we're trying to like, as well as the direction of the vote. And what I mean by direction is, do they want to vote on the post or do they want to remove a post? Because like any application, maybe you accidentally clicked on a post to like it, but you realize you don't want to like it, so you click on it again to remove that. So vote direction of 1 means that we're going to like the post, and then a vote direction of 0 means we're going to remove our like of the post. Now in our routers folder, we're going to create a new file, which is just going to be vote.py. So this is going to handle all the routing for our voting URLs. And what I'm going to do is I'm just going to copy the import statement from one of the other routers. And we'll set up our route. So let's set up the decorator first. And this is going to be a post. And I actually have to import router. We got it. Let's create our router instance. So we'll say router equals API router. And we'll set up the prefix to be /vote. And the tags, we're going to give it its own section, which is going to just say vote. And so now we can do @router.post. This is going to be a post operation because we have to send some information to the server. And the URL is just going to be /. So it's just going to be /vote then. And since we're going to create a vote by default, we're going to send a different status code. We're going to send a 201 instead of the default 200. Then we'll define our function, which I'll just call vote. Now there's going to be a couple things that we have to pass in. So since we expect the user to provide some data in the body, it usually means we want to define a schema just so that we can ensure they send us the exact information. So let's set up our schema for voting. We'll create a class called vote. And so the first field should be a post ID, which is going to be of type int. And then we're going to have a direction, which is going to be an integer as well. So it's either 0 or 1. However, I would like to be able to validate it to ensure that it's only 0 or 1. I couldn't exactly figure out if there was a way to do that in Pydantic, but one thing we can do is we can use conint. So we'll import that from Pydantic automatically. So if you want to see the import, that's what it's going to look like. And we can say less than or equal to 1. So anything less than 1 is going to be allowed. The only problem with this is that it allows for negative numbers, but that's okay. If you guys figure out how to just specify 0 and 1, then go ahead and replace that, and definitely leave that piece of information in the comments so that anyone else who wants to set up that specific restriction, then we all know how to do that moving forward. And let's import our schema now. So we'll go up a directory. And let's also import database, models, and we're going to have to require the user to be logged in before they can vote on something. So let's import OAuth2. And so here, we're going to set up the schema. And we're also going to set up the database so that we can make queries. And then lastly, we'll get the current user. So once we get all of those dependencies, looks like we have to import session as well. And I'm actually going to move this right below the first import. Not that it matters, but. And so we're going to set up logic for when the vote direction is 1. So if vote.dir, so we're pulling the direction from the vote schema, equals 1, then we're going to perform some logic. Else, if it's 0, then we're going to perform some other logic. So if we want to create a vote, the first thing we're going to do is query to see, does the vote already exist? And so what I'm going to do is I'm going to say db.query, and we'll grab models.vote. And I'm going to filter based off of models.vote.post_id. And we're going to say it equals vote.post_id. So we're going to see if there's already a vote for this specific post ID. However, this isn't enough because remember, multiple people can vote on the same post. So we actually have to do a second check. And we can add in a second condition by just doing a comma and then providing the second condition. So we have to say models.vote.userid equals current user.id. And I'm going to save this, and we're going to call this vote_query. So this isn't going to actually query the database yet. This is just building out the query. And it's going to check to see if this specific user ultimately has voted for this specific post already or liked this post. And I'm actually going to move this above the if statement. And you guys will see why we're going to do that in a bit. And we're going to then perform the query and just save that result under found vote equals vote_query dot first. All right. And so if the user wants to like a post, but we already found a post, that means he's already liked this specific post, so he can't like it again. So what we're going to say is if we already found a vote, then we're going to raise an HTTP exception. Now the status code, we're going to use a new status code. I'm going to use status dot, and then this is going to be a 409 for conflict. And there's other status codes you could potentially use. I just decided that this is probably going to be the best fit. And then for detail, we're going to just pass an F string and say user, and then we pass in the user, which is get current_user.id. Has already voted on post with an ID of vote.post. _ID. All right, but if we didn't find a vote, then what we're going to do is we're going to